Here we go. Multiplying matrices, right? So we got our rectangular arrays here. We talked about adding and subtracting them yesterday. Now we're going to get into multiplying them. Okay, so matrices A and B, we're just making up things here now. Matrices A and B can multiply if and only if, so we did this yesterday, let's do this again. If and only if the number of rows, sorry, my bad, the number of columns, this is important actually, the number of columns in matrix A equals the number of rows in matrix B. Okay, so if the number of columns in matrix A equals the number of rows in matrix B, then we can multiply these two matrices. All right, so the way this works is, let's say matrix A has dimensions m by n, okay, and matrix B has dimensions n by p. See what I did there? The columns is the same in A as the rows is the same in B. If that's the case, then we can multiply these two, and this would be the result of that, right? That's A times B when we see that, right? So that's matrix A times matrix B, and the result of that is going to be dimensions m by p. See how that works? Okay, so here's how I want you to notate this, okay? So we're going to do something like this. We're going to confirm that these can be multiplied by boxing in the columns of the dimensions from our first matrix and the rows of our dimensions of our second matrix. If those two are the same, we're going to put a check mark up here, and then we know that the resulting product is going to be the rows from matrix A by the columns from matrix B. Okay? All right, before we dig too far in, let's do this. I want you right down here out in front of each one of these to write the dimensions of each of these matrices. All right, let's go ahead and do that first, and then we can talk about multiplying. Go ahead. This down, you should have put this right here. So we got a 4 by 3, a 1 by 5, a 2 by 4, a 3 by 1, and a 5 by 2. Yeah? Everybody good? Okay. All right. So let's talk about, can we multiply matrix A times matrix D? And what we want to do is this. Okay. What I want you to do is I want you to write the dimensions for A and the dimensions for D. So like A is a, whoa, that one there. We don't want that. A is going to be a 4 by 3. And D is going to be a 3 by 1. And so what we're going to do is we're going to box in the columns from A and the rows from D. And if those numbers are the same, we're going to put a check mark. That means yes, we can multiply these. So we'll say yes. And then the product's dimensions are going to be what? It's going to be a 4 by 1, right? So picture what that's going to look like in your mind. A 4 by 1. You should have been picturing a column matrix, right? A, B, C, D. 4 rows, but only 1 column. Column matrix. Okay? Good? That's easy, right? Okay, let's do number 2. AC. Let's see what you can do. Go ahead. Write it out like the way I wrote out the first one. So you should have come up with something that looks like this. So I just put a slash mark through that box if I can't multiply, because my columns in matrix A do not match my rows in matrix C. So that is an undoable multiplication problem. And as we get into when we get into doing the multiplication part, you're going to see why this has to be in place for us to be able to do that. Okay? Got the idea what we're doing here? All right. I'm going to give you about 2-3 minutes. I want you to finish up 3 through 8. All right, 3 through 8. Either you can or can't multiply them, identify the dimensions, and notate it accordingly. Should have come up with right there. Now, the question that we're going to see in a little bit is can we flip-flop these? And in certain cases we can, and in certain cases we can't. So we'll have to look at that, whether we flip-flop or we multiply by other things, important for you to know. Okay? All right. Good so far? Okay? So before we can multiply, we got to see if we can multiply. And I'm going to need you to document that on your multiplication problems. Okay? All right. So let's talk about how to do some multiplying. All right? I think this explanation is really confusing. And so I'm not even going to read it. All right? I'm just going to let you, if you want to look back on it, you can, but I just don't, it's too confusing. I don't like it. So, okay. All right. Let's do this. Question. Can we multiply A times B down here? Yes. Sure, right? Because what do we have? We have a 2 by 2, and we have a 2 by 2, right? Which means that this checks, and we're going to be resulting with a product of what? A product is going to be a 2 by 2. Okay, so let's do this. Let's come over here, and let's give ourselves a little space to write. Okay? And what I want you to do is, I want you to do some circles here. So we're going to go like this. Swoop, and then a swoop, and then a swoop, and then a swoop. Maybe this one needs to be a little bit bigger. All right? Wes, come here. You're going to want to grab that first paper closest to the colored pencils, okay? All right. So you're going to do some swoop and swoop and swoop and swoop. That's our 2 by 2 right there, okay? So our result needs to be a 2 by 2. Now, I want you to think about something, right? I'm just going to name these elements with an N. So this first element right here is going to be N11. Right? Row 1, column 1, yeah? And this is going to be N what? N 1, 2, right? Row 1, column 2. And this is going to be N 2, 1, right? Second row, first column. And then this will be N 2, 2. Great. Okay. Now, here's the way the multiplication works. If this right here has to come from row 1 and column 1, you're going to want to grab that first paper right there by the colored pencils. That one. Yep. Okay. Then that means that this has to be the result of a multiplication problem involving row 1 and column 1. See that? And we're going to multiply the elements that are in the same corresponding positions, right? So if this is the first element in row 1, it's going to multiply by the first element in column 1. And this is the second element in row 1. We're going to multiply by the second element in column 1. And so the way this is going to work is you're going to end up with A times E plus B times G. That's how you're going to get N11. Again, we're taking the first row and multiplying it by the first column. Does that make sense? Does everybody see what we're doing? So then it's first element times first element, second element times second element. Okay, why don't you write down what you think is going to be multiplied for these two right here. Go for it. Write it down, give it a shot. Let's see if you can get it. Gotta go. Put AF plus BH. Right? So we're talking about, in this case, this is going to be from row 1, column 2. So it's going to be row 1, column 2. First element times first element, and then second element times second element, like that. Okay, why don't you do those two? Write in the letters that are going to form those multiplication problems. Go ahead. Put CE plus DG and CF plus DH. Good? Make sense? Everybody okay? All right, that's how we're doing it, okay? So Again, you're welcome to read that explanation, but I think that just understanding, right here, Taylor, you're going to want to grab the first paper next to the colored pencils. Okay, here we go then. Let's do some multiplying of matrices. All right, so first thing I want you to do right here, we're going to do this one together. First thing I want you to do right here is I want you to write out some justification as to whether or not you can or cannot multiply. And if you can, what is the product dimensions going to be? Go ahead and do that. Okay, so we're going to have a yes on the multiplication because our columns from the first one match our rows from the second one. And then our product dimensions are going to be what's left over. Rows and columns. All right, so you're going to need to show me one level of work right here, okay, that's going to have the addition problems in it. So I want to see what numbers are you multiplying and then adding. So you're multiplying two numbers, multiplying two numbers. I want to see the addition problems, like here, like we just did. And then you can calculate all that up and then give me a matrix answer down here. All right? Let's see if you do it. Get a little checkpoint and see if you're moving in the right direction, all right? If you're moving in the right direction, you should have been doing something like this right here. Okay? Now, you don't need to write the circles in there, and I'm not going to do that every time, but I'm just putting them in there so you can get an idea of the blank spaces for the 2x2. But that should be the first level of work right there, right? Which that comes from, again, this is from row 1 times column 1, right? And it's the first element in the row times the first element in the column. And then it's the second element in the row times the second element in the column. And that's where I get the negative 24, positive 45. And then in my answer, that's where I would add these two together to get my first N11 or A11 or whatever you want to call that element there. Okay? All right, finish it up. All right, here we go. Let's take a look. You should have come up with this right here. Check your work, check your answers, okay? Questions? Not too bad, right? It's just keeping track of everything and paying attention to the details, okay? Now, one of the benefits also for you right here is when you do it like this, it makes it very easy for you to go back and check your work, right? Because you can easily check this circle here by going, okay, yes, yes. And then you can easily check your answer here by adding that and matching it up. So it's an easy way to check your work, too, by keeping it organized as we go through it. What do you think? Not bad? All right. How about we do number 11? And I'll give you some checkpoints along the way. First, up here, tell me whether or not you can or can't do it and what the product would be if you can. And then, let's see what you can do with writing out your work. All right, go ahead.
It's going to be a 2x1. How can you use a 2x1?
Checkpoints along the way. You should have said, yes, I can multiply these. I got a 2x3 and a 3x1. So then the remaining rows and columns is going to be a 2x1. Picture what that looks like in your mind. What does a 2x1 look like?
Okay, now I see. I got that locked down. So
Okay, keep going. Checkpoint along the way. If you're tracking, you should be somewhere along here, like that.
Okay, yes. All right, go ahead and check it out.
And actually, here's a good place for you to start to understand why does it end up being these dimensions here, right? Because if you think about it, if I'm doing for my my columns, I'm doing row 1 times column 1. Well, there's only one column, right? So then it's going to be 3 multiplication problems added together. First element in the row times first element in the column. Second element in the row times second element in the column. Third element in the row times third element in the column. And so this is going to be the result of that, which is going to bring down just one more item, 3 numbers here, And that'll end up being, again, another column matrix with a number and a number like that. Okay? All right, you finish it, and then we'll take a look at the answer.
2 by 2 times 2 by 3.
Go. Should have come up with this matrix here, 83 over negative 32. How many people got that right? Let me see. Good, 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 good. Nice, nice. Okay. All right. 12's a little tricky. 12's a little tricky. Let's see what you can do with 12. Go for it. First, tell me if you can or can't do it. And if you can, what's the product going to be? And then show me some work and do it. Okay? No checkpoints along the way this time. I'm just going to give you the answer. Okay? And we're not going to do all of these. So, I mean, if you get done early and you want to do a couple more or one more, you're welcome to try, but we're not going to do them all. So you can either just wait until we're done or whatever. So, okay?
1 by 3.
No, 1 by 4. Rookie mistake, Jack.
Here's what you should have come up with right here.
Oh, yes, indeed.
Okay? Right? Here are your 4 elements. And again, if you're struggling seeing it, you can use the circles to help you figure it out. See, so there's a couple of clues in this. This is not just wasted time up here. This helps you know what your answer needs to be. And once you know what your answer needs to be, then you can set up a blank template, 1 by 4, and then you can start thinking about, well, what goes in here? What goes in here? What goes in here? What goes in here? And again, if you remember your element numbers, right, this one right here, what is this element number? Let's call it A. Element what? A what? What's this one going to be? If we had to denote it, give it a notation. What's it going to be? This one. A what? A13, right? There's going to be A sub 13, right? Row 1, column 3. And that has to result from a multiplication problem of row 1 times column 3. See the numbers? 2 times negative 4 is negative 8. Negative 8 times negative 5 is negative 40. That's row 1, column 3. Once you start seeing it and it starts clicking, it's going to make a lot of sense. And that's why it just takes practice. All right, so let's do one that's got some deep practice for you. All right, let's go ahead and do 13. All right, let's do 13. And again, keeping track of everything, keeping it clear. Make sure, now listen, hey, when you're writing your work, okay, please make sure that you're leaving spaces in between your element numbers, right? If you write it all like one big problem all the way across, I'm going to think you mean one big element. This is one element right here, right? Because this is going to end up being a 2 by 1, right? So this math problem is one element, but this is a set of separate elements. Keep some spaces in between those so it's clear in your work when you're doing your addition problems, so you're making your elements very clear. And again, if you want to use the circles, you're welcome to do that, okay? All right, you're working on 13. Go for it. Take a look. Here's what you should have come up with right here. So again, use your columns or your circles if you want to help you out, right? Again, so and again, you can also write your element numbers in there to help you out as well too, right? So you could be like, all right, this is N11, N12, N13, and then that may be serving as a reminder for you that this has to be a result of row 1 times column 1. So then it's row 1 times column 1, and then it's just first element in the row times first element in the column. Second element in the row times second element in the column. If there were 3, it'd be 3 times 3. And that's why we have those lined up. That's why we have to do this right here. So, okay, all right. Let's keep this train rolling, okay? So, here we have matrix A and B. All right, matrix A and B. And so the question is, find AB and find BA. Why don't you partner up with somebody and one of you find AB, and the other one of you find BA. And let's do this. Let's do a little squiggle down our paper here like this, all right? Let's do a little squiggle down our paper, and let's do AB over here. So whoever's finding AB, work over there. Whoever's finding BA can work over here. All right? Let's find those results of those two math problems. Go ahead. Look and see if you came up with A, B, and BA. Here's what you should have gotten.
I just about did it. All right.
That's good. Which one did you get right?
I got BA right.
Okay.
That's what I did.
All right. All right. So now what you'll notice is that the product of AB is not an equal matrice with the product of BA. Because remember, we talked about yesterday, equal matrices means that every corresponding element must be exactly the same, and those aren't. So that means that the commutative property does not apply to matrix multiplication. So don't make that mistake when you're doing a multiplication problem. If you're asked to do CD, don't mistakenly do DC and think you're going to be able to come up with the same answer, especially when you're dealing with square matrices, right? Because they both produce 2 by 2 answers.
That's exactly what I was doing.
Or 3 by 3, or 4 by 4, or 5 by 5, because we have all different kinds of square matrices. All right, so I'll leave that up there for you to copy down while I'm passing out your next set of notes for us.
One-sided at least.
Yes, one-sided.
Challenge.
There we go.
Uh-oh.
I'm mad at it.
Oh my god.
Why do you like fuss with
I know.
Wait, what's the matter? Just give me my money. I didn't guess that.
No, it's
Next level plays.
Taylor's
just a fan. Rigo Bird.
no, it makes sense. It makes sense. Carolina, there we go.
Does that make sense?
It's like sweatpants.
Oh!
Yeah. Really?
I think it'll be fast.
That's up to you. I don't want you to miss it.
I see, but we're through the corners. No, it's because
Okay, let's go. All right, so there are some properties of matrices that do apply. There are some properties that do apply, so let's just kind of jot these down. We're not going to work a ton with these, but I'll just give them to you so we know. So the associative property does work. So if we had 3 matrices being multiplied, just like with regular multiplication, we would do the first multiplication problem and then multiply by the result of that. Or we could do it the other way around, where we multiply B and C and then multiply by A. That property does work. But you'll notice the reason why that works is the order in which we did those multiplications, those matrices, remains consistent across. We didn't switch up C to B to A. So we're not commuting the matrices within there. We're maintaining that. We're just regrouping how we do the multiplication. Okay, because the commutative property doesn't work, but regrouping them does. Okay, associative property of scalar multiplication. So we're going to use K as our scaling variable. So K times A times B, like that, could be done K times A and then multiply by B. Or it could be A times K times B. So when you have scalar multiplication, right, that's the one we did yesterday where we take a number and we scale up or down or into the negative each of the elements with a constant, right? We can scale either of the matrices we're multiplying first and then multiply by the other matrices. Again, maintaining that same order that A is on the left and B is on the right. Okay, now you'll notice these are a little weird. Left distributive property and right distributive property. That's a little strange, right distributive property. But it's true, we have this. And so it would look like this. C times A plus B is going to give us C times A plus C times B matrices, okay? So distribution, as we're used to seeing it, works in this case. Matrix C times matrix A, matrix C times matrix B is going to give us C times A plus C times B. Okay? Now, let's say that we move the C to this side. We might be tempted to say that it's going to be CA plus CB, but it's not, because we know that the order in which we multiply these things matters, right? Because we have to keep that order in place, and so this is going to be AC plus BC. See that, right? Because CA and AC are not the same thing, because commutative property does not apply to matrices. So we have to actually have a left distribution and a right distribution. Now, we're not, like I said, we're not going to get into all of that hoopla in terms of doing these, but just so that you know they're there. All right, so let's put this into some applications now with some word situations, right? Okay, so here, and this again, this is right where your spreadsheets come into play, right? This is exactly what we're doing with our tables. We take our two different sheets and then we log our data into those sheets, and then we import that data and we do math with it, and we withdraw pieces of information. And so here, the first table shows Mrs. Smith and Mrs. Wells and what they purchase in terms of boxes of reams of paper, boxes of dry erase markers, and staples as such. Okay, and then we have the cost for a ream of paper, a pack of dry erase markers, and a box of staples, okay? And so what we want to do is we want to use matrix multiplication to see if we can come up with the total cost of supplies for each teacher, all right? Question. What's the dimensions of this matrix right here?
2 by 3.
Okay, this is a 2 by 3. Okay? What's the dimensions of the supply item matrix?
3 by 1.
Okay, this is a 3 by 1. Will we be able to multiply these two together?
Yes.
Yeah, and what are we going to get as a result? 2 by 1. All right, now, you'll notice the 2 by 1 is going to be a combination of the rows and the columns. 2 by 1. 2 rows, each row will represent a teacher. Each column will represent a cost of an item. 2 by 1. Do it. Go.
Let's see. Wait, so it's
I'll give you some checkpoints, all right? Go ahead. We're back on now. We'll leave that off for that conversation. All right, here we go. Take a look. See how you did. All right, Mrs. Smith got $118.50. Mrs. Will spent $135.50. All right. Okay, let's just so we're focused here, right? So this is our working within our spreadsheet. This is our matrix C math, right? And then this is the interpretation within the context of the story. And I do need to see both of those as you're answering these questions, right? So I need to know that you can do the math and use the tool of matrix multiplication, but then the answer needs to be interpreted. Yeah.
Do we need to show the first two?
So no, you don't need to show this first ones here, but it might be helpful. Like, for example, in this next question, how many matrices do you see?
A lot.
1. There's only 1, right? Because this is a matrix, right? But how are we using matrix multiplication then if there's only 1 matrix? Well, there's another one buried in here. let's see if you can get this set up. Get how far. Let's see how far you can get with this one, and then we'll take a look at the answer. But let's see what you can do with 19. I would recommend for 19, write out your matrices, and you might want to start like over here just to give yourself plenty of room to work across because it's a little bit of a big problem. Okay, give it a shot. See what you can do.
Okay, if we do that, oh, it works. It doesn't work. Oh, that does work.
Okay, so here's the answer to 19. I gave you guys the multiplication problem. Again, remember that these are the 15% numbers built in right there. And then you work your way through it. Of course, I mean, you can do a net one too, but then you have to reduce those values by 15%. And then again, you're just doing application here. So just check and make sure that you got those right. And then let me know if you got any questions, all right? Hasta la vista.